All right, so we need to find the slope of the tangent line for this function. Once again, that means we are using that formula that we talked about, or the limit that we talked about, the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, the good news is I am given f of x right here, and that is going to go here. I just have to figure out what f of x plus h is. So I'm going to work that out over on the side here. Okay, so f of x plus h. All right, so I'm just going to replace all of my x's in the original expression with x plus h, and I get this. Now, there's not a whole lot of substitution that can happen there. So what I know is that that expression is what's going to go in here in my limit. So let's go ahead and start substituting some things in here. So I've got the limit. I always forget to select pen again. The limit as h approaches 0 of f of x plus h. Now that's just the square root of x plus h minus 5 minus, and then we have our original function f of x, which I've highlighted in yellow. So minus the square root of x minus 5, and that's all over h. Now there's really nothing we can do in this expression right now that'll allow us to eliminate h as a factor in the denominator. So we're going to use our strategy of multiplying by the conjugate, which is essentially just trying to create a difference of squares in the numerator. So we know that we're going to multiply the numerator and the denominator by the same thing. And we're going to just take whatever's in the numerator, which is square root of x plus h minus 5, and the square root of x minus 5. But instead of subtracting like we see here, we're going to add, because then that creates a difference of squares. And then whatever I do in the numerator, I've got to do in the denominator so that we don't change the value of the original expression. And we've looked at a few of these, and we've talked about how in this situation, because we've created a difference of squares, the multiplication of this, although it looks scary, is not that bad. By creating a difference of squares, we know that the middle terms are always going to be 0 when they combine. So we can just quickly say, all right, we can multiply the first terms together. And really, that's just taking something and multiplying it by itself, which is squaring it. So a radical squared, square root squared, is they're just going to undo each other. So what we're left with is just x plus h minus 5. And then we're going to subtract, again, multiplying something times itself, we're going to subtract x minus 5. But I always put that in parentheses so I don't forget to subtract both parts of that. Now here's where most of you will make your mistake. Yes, we still have h in the denominator. I'm not going to multiply out, I'm not going to distribute the h in this expression because I want to be able to create a giant 1. And if I distribute that h, the ability to create the giant 1 with the h becomes a little bit tougher. So let's go ahead and simplify the numerator a little bit. So we have x plus h minus 5, and then minus x minus negative 5 will be plus 5. And then we have that kind of complicated looking denominator. And then in our numerator, again, we see the things that don't have an h with them become 0. So what's great here, and I'm going to move this up because I'm running out of room, the limit as h approaches 0 of, we just have h in the numerator. And that's kind of what we were hoping would happen because we want to be able to cancel that or get that giant 1 with the h in the denominator. And now that we have that h in the numerator, we can go ahead and create that giant 1. So we have the limit as h approaches 0 of 1 over the square root of x plus h minus 5 plus the square root of x minus 5. Now, at this point, there's no more h's that are going to create a problem for us in the denominator. So we can go ahead and just substitute in a 0 for h. Now this is where, sometimes when you write your answer, it can be a little interesting. It's going to be 1 over the square root of x plus 0 minus 5, which is just x minus 5, plus x square root of x minus 5. Now that's not bad, but what we have is we have 1 square root of x plus 5 plus another square root of x plus 5, so we really have 2 of those things, minus 5. and this is how you will see your answer written.